Okay, this is going to be a generic lesson on sine and cosine, focusing on the SOH CAH TOA method, finding the missing parts of a triangle. So a quick review: opposite, adjacent, and hypotenuse. Everything is from the theta's perspective. This one little point. This side is touching theta, but it's not the hypotenuse, making it the adjacent. The hypotenuse, the longest side, the direct distance from A to B, is your hypotenuse. It's always across from the 90 degrees. Opposite, well, it's exactly as it sounds. It is the opposite side of your theta. Easier way to remember SOH CAH TOA is a sentimental old hippie called another hippie tripping on acid. All of them are just proportions of fraction. Sine of theta is equal to opposite of hypotenuse. Cosine of theta is equal to adjacent divided by hypotenuse. So, as I said in another video, it's all about the proportions of one side divided by the hypotenuse. Sine is in relation to opposite, cosine is in relation to adjacent. Let's look at some numbers real quick. There we go. So if we put the sine of 30 into a calculator, 30 sine, we get 0.5. So we know with a triangle that has an angle of 30 degrees, the opposite side is going to be half of the hypotenuse. Cosine of 60 cosine, another half. The adjacent side will be half the hypotenuse. And we can keep this up. 25 sine, we get 0.4226, essentially saying the opposite side is going to be 42.26% of the hypotenuse length. So if we know the distance of the hypotenuse and an angle, we can find the opposite and adjacent sides of a triangle. Keep in mind that this only works for right triangles. So if sine of theta is equal to opposite of our hypotenuse, we can say the hypotenuse times sine of theta is equal to opposite side length, similar to adjacent side length. Hypotenuse times cosine of theta, we get our adjacent side length. Essentially, we're just trying to figure out what's missing. Using that hourglass rule I went over in the other videos, our opposite side would be our changing of eastings, while our adjacent sides will always be the changing of northings. This is assuming we're drawing our triangles with our north-south line first, then our east-west side, then connecting the dots. Doing it makes your life so much easier. Now let's talk about arctangent and arcsine, the inverses of sine and cosine. Let's just say if we have side lengths but we don't have an interior angle, we can use our arctangent. The arctangent, all you have to do is press the second button and either sine or cosine, depending on what we're doing at that time. Let's do one of these things together. So let's do the top triangle first. We're trying to find this bearing right here, or this angle, and we're given an adjacent side and a hypotenuse side. That tells me we need to use a cosine variation. Because we only have side lengths and we don't know an angle, we're going to use arc cosine, the inverse of cosine. So we can say (10) divided by 15, we get 0.666. Let's throw that into our arc cosine. We have 48.1896 and so on. This is a decimal degree. Everything is nicer in degrees, minutes, and seconds. this tells me that this interior angle, this bearing is 48 degrees 11 minutes 22 seconds and 8. That says we're going to go southeast, assuming we're going from A to point B. We travel south and then we went east, so southeast. We can also do the same thing for the bottom triangle. With this, we don't know this angle right here, but we have an opposite and we have a hypotenuse using the hourglass method. We can say 20 divided by 40 with 0.5. We press second and then we press this nice sine button. We get 30 degrees. That tells me that this angle right here should be 30 degrees. And we can check both of these guys by just putting it into the standard variation. So 48.11, I'm just gonna say call it 23 for rounding. Change that to decimal degrees. Throw that into a cosine. Times it by 15. And if we did this correctly, it should pop up to 10 or pretty dang close to 10. And this is pretty much close to 10, so that proves that this is right. Now we can do the bottom triangle. Let's do this check. 30 sine 0.5 times 40, we get 20. This just proves that the inverses prove each other right. So this is the little flowchart I made just to determine if you do not know which one to use. So your first question is, do you know an angle on one side? Yes or no? If you do, you essentially want to see from the angle's perspective, are we using or trying to solve opposite or adjacent? If we're doing opposite, we use sine. If we're using adjacent, cosine. If we don't know an angle and one side, we ask ourselves, do you know the length of the hypotenuse in one either side? There are two options, yes or no. If it's no, then chances are we shouldn't be using sine or cosine, we should be using a tangent. If the answer is yes, from your perspective, essentially if we know two sides, one hypotenuse, we're going to be, depending on what we're using, we're going to use arcsine for opposite, adjacent will give you an arc cosine, and this is going off the hourglass rule. Well, this can actually be used for all triangles, but if you do the hourglass rule, it will be equal to your eastings and their things.